Hello students, let's talk about the second stage of two-stage least squares. We have a structural model where y1 equals beta naught plus beta 1 y2 plus beta 2 z1 plus u1. We talked about the first stage where we can get the best instrumental variable for y2 as a linear combination of the instruments z2 and z3 and the exogenous explanatory variable z1. We get that estimate instrumental variable y2 hat. The second stage is to plug y2 hat into the structural equation. We'll run this. We can then run this equation, regress y1 on y2 hat and z1 and get an unbiased estimate of beta 1. Alright, so what we're doing is using the version of y2 where the correlation of y2 with u1 has been purged by keeping only the part of y2 that is exogenous to u1 as a function of the exogenous instruments in this second stage. Briefly, there are a few things to keep in mind when using the two-stage least squares method. Number one, if you have k endogenous variables, that is explanatory variables, you will need at least k instrumental variables. And number two, with two-stage least squares, it is possible for the r squared to be negative. It can be hard to interpret the r squared with two-stage least squares, and there's no guarantee that if we're looking at restricted equations, that the total sum of squared residuals from a restricted equation is greater than or equal to the sum of squared residuals from an unrestricted equation. So interpreting the r squared and computing f-stats using the usual methods are not advised. If we want to compute f-stats, we can use Stata's test command. Stay tuned to the next video. We will discuss the instrumental variables solution to the errors in variables problem.